Today's lesson is on probability. You've already learned the important formulas and concepts about probability in the first video, and in this video, I'm going to spend the whole time going over some of the trickier concepts. Let's take a look at this first example. The deck for a game is made up of 108 cards. 25 each are red, yellow, blue, and green, and 8 are wild cards. Each player is randomly dealt a 7-card hand. What is the probability that a hand will contain, for part A, exactly 2 wild cards? Exactly 2 wild cards. Well, when we're thinking about probability, remember we would need to think about the probability or the number of events for the particular question out of the total number of events. So the probability of the event, remember, is the number of events out of the number in the sample space. So let's start with the denominator. The denominator, or the sample space in this case, is the number of ways to be dealt a hand of 7 cards. So the number of ways to be dealt a hand of 7 cards is some combination of the 108 cards in the deck were dealt 7. And then the numerator, we would need to think about the number of ways that this event can happen. And for part A, we're trying to figure out the number of ways that we can get exactly 2 wild cards. Exactly 2 wild cards. Well, let's first think about the number of ways that we can get 2 wild cards. There are 8 wild cards, and we want to choose 2 of those 8. So it's tempting to be done here and pop this into our calculator, but we haven't guaranteed that we're only getting 2 wild cards until we figure out how to fill the rest of the 7 cards in our hand. So 2 of them are going to be wild cards, but we still have to pick 5 not wild cards. Well, if there were 8 wild cards to choose from, there are 100 not wild cards to fill up the other 5 spots in our hand. So the probability of this event happening is the number of ways that we can get exactly 2 wild cards and 5 not wild cards out of the total number of ways to deal 7 cards with this type of deck. So this is the setup. Please use your calculators to compute, and the answer is 0.0756. For part B, what is the probability that a hand will contain 2 wild cards, 2 red cards, and 3 blue cards? So this time, 2, 2, and 3, they're telling us exactly how to fill up our hand of 7. So again, the denominator is the total sample space. In this case, the total number of ways that we can be dealt 7 cards out of a deck of 108. So some combination out of 108, choose 7. To get 2 wild cards, it's going to be some combination of the 8 wild cards, choose 2. To get 2 red cards, it's going to be some combination of the 25 red cards. We need 2 of them, choose 2. And 3 blue cards, some combination of the 25 blue cards, choose 3. So again, you can type all this in your calculator and compute, and the probability is 0.0006929. All of them, oops. Example 2. A company sells batteries in packs of 10 and knows that 3 out of every package are defective. So it's helpful to think about the total in the package being 10. And of those 10, 3 are defective. So I'm going to just click the wrong button there. We can call 3 of them bad, which means that the other 7 are good out of 1 package. You randomly select 4 batteries out of a pack to power your sweet new drone. So you're going to take out of this package 4 of them. And what is the probability that, in part A, all 4 batteries work? All 4 batteries work. Well, let's think about that in terms of a probability of an event. Probability of this event is the number of ways the event can occur, the number of ways that we can get 4 good batteries, out of the number in the sample space, the total number of ways to pick 4 batteries. I'm going to start by thinking about that denominator again. The total number of ways to pick 4 batteries in this case is out of the package of 10, choose 4. The number of ways to pick 4 good batteries is some combination out of the 7 good batteries, choose 4. So this is our setup for part A. You can pop this in your calculator and you can simplify. It ends up being 35 over 210, which simplifies to 1/6. So we have a 1/6 chance that all 4 batteries are good. Part B, what is the probability that all 4 are defective? Well, this is kind of a trick question. If you look carefully at the setup, there's only 3 defective in each package, so there's no way that all 4 of them can be defective, so that probability is 0. For part C, what is the probability that exactly 1 is defective? Well, our denominator, again, our total sample space, are the number of ways that we can choose 4 batteries out of a pack of 10, combination, out of 10, choose 4. To get exactly 1 defective, well, how many ways can we choose 1 defective? It's some combination out of the 3 that are defective, choose 1. But to guarantee that exactly 1 is defective, we need to think about the other 3 being good. So we also have to guarantee that we're going to choose out of the 7 good batteries 3 more. So at this point, you can put in your calculator and you should get 3 times 35 over 210. If you simplify, you get 1/2. Part D, what is the probability that at least 1 battery is defective? What is the probability that at least 1 battery is defective? Well, there's a long way and a short way to figure out this question. And let's first think about the sample space and the number that you could possibly have that are bad. Well, you could either have 0 that are bad, or 1, or 2, or 3, or 4 bad. And the probabilities of these must add up to 1. So one way, and the long way that we could figure this out, is the probability that exactly 1 is defective, plus the probability that 2 are defective, plus the probability that 3 are defective, plus the probability that 4 are defective. This would be the same as the probability that at least 1 battery is defective. This is going to take a lot of work, but it's doable. The easier way to think about that, and if we go back over here to the idea of the sample space, the probability that at least 1 is defective includes all of these. The only one left is that none of them are defective. And that's the complement, because all these add up to a probability of 1. The probability that none are defective is the complement. So we can say that this is equal to 1 minus the probability that none are defective. Another way to say that none are defective is to say that all of them are good. This is the same as 1 minus the probability that they are all good. The probability that they are all good is what we figured out in part A. So we can just say 1 minus 1/6, which is 5/6. That's going to be it for our lesson today. Thanks for watching.